Hi everyone, and welcome in this quick update about our demo RuleOps. This demo is brought to you by Luca, Daniele, and myself. So actually this is a chance for me to say right now that if you find the content interesting from this video and presentation, please do feel free to reach out for us. We will be really happy to hear your feedbacks and your comment, your thought about this content. As an introduction, we have here a picture of a typical day in the life of a DevOps engineer as they are trying to debug their operational problem in their Kubernetes cluster. And we would like to argue that it doesn't have to be that way. So beyond the jokes and the memes, what we would really like to pay attention to as an introduction is that in Kubernetes, the etcd key value store is used as the source of truth. However, we are lacking some transactionality when we do the application through kubectl apply of different resources at different stages. So this means that you may have to act on different resources at different times sometimes, and that could lead to an inconsistent state of the cluster, and the possibility that this is reached is of course quite proportional to the amount of time that you will play a modification on these cluster resources. So what we would really like to do with this demo is to put more dev skills inside of DevOps, meaning that from the software development principle actually, we have a lot of debugging activities which are at the core of our discipline. And the debugging activities can also be further complemented with a lot of automation, artificial intelligence, as we will see in this presentation. And we really don't want to overlook a potential opportunity for process improvement in really operations on the Kubernetes cluster. So we know that AI these days is quite a buzzword term, but what we really mean in the context of this presentation is a very pragmatical AI approach, specifically focusing on rule engine, what is called sometimes as expert system. Really, it is about symbolic AI and knowledge representation and reasoning. So throughout the content of this video, when we will refer to AI, please do keep this introduction in mind. So let's see what are the opportunities here. We believe actually that a quick Google search can sometimes really make evident in front of our eyes what is the reality of a lot of operations. Specifically, debugging Kubernetes on any search engine really returns a lot of results. And to complement that, if you see in YouTube or any other video platforms, you will find a lot of videos, maybe sometimes courses, training resources that are really dedicated to the debugging operation on Kubernetes cluster. So it means that it is something that is not quite straightforward or lean as we may want, at least in 2022. However, it is also a skill that people may need to acquire. So further, all of these resources, all these training activities, all these blog posts or videos are often complemented with some attached resources like that looks like a flowchart. What we would really pay attention to is that here what this visual diagram actually do for us is that they have a very high level way to express some semantic reasoning. Something like if this do that, or something like please check this one first, if this fails then check these other things, in a way to inspect what could be the root cause of the problem, and then further, then we will know what we need to do in order to correct it on our cluster. So this is an opportunity for us to automate it. And here is where the terms RuleOps come from, is an evolution of the term DevOps name. So DevOps is a compound name that brings together development and operations. And here we would like to play on the term and really mix together rule, as coming from rule engine, with operations. So we believe that the declarative power that can be expressed with the rule definition, together with a lot of the features that are typical of rule engine, such as Drools, really make it a perfect fit for really debugging, inspecting, and automating a lot of this semantic reasoning on the cluster resources and on the cluster status. We will see that through the demos on this presentation. For the first example, I would like to make reference to a tutorial in the Kubernetes documentation titled Configure a pod quota for a namespace. In this one, if you follow this step, you will be guided in creating a resource quota and then a deployment that doesn't fit in said quota. What I've already prepared here is a Minikube following that tutorial, and as we can see, the deployment is grayed out. So this deployment is grayed out. Of course, we know why it is the case, because we followed specifically that guide. But typically, you are helped with the, say, example flowchart that I was mentioning earlier. You will find a step or a specific type of reasoning, a specific type of really topic discussion that will hit the resource quota. And here is where actually we can make a rectification if the pod is currently pending because of that. So now we can have this one automatically done by some simple rule definition. In fact, we have our Drools RuleOps here, and as we can see, we already a message that clearly explains to us what is happening. We need to relax the resource quota because some deployment is pending for the pod quota demo, exactly as we would expect. And this can be defined quite simply with a semantic rule definition. In this case here, you see that we are actually playing with the domain model of Kubernetes, and here we are really correlating some deployment condition on the deployment. And this is actually a first example on how to implement with a declarative rule exactly what a visual diagram is telling us to do. We can move now to the next example demo. In this other example, I would like to make reference to another tutorial in the Kubernetes documentation titled Configure Memory and CPU Quota for a Namespace. Actually, I almost followed this tutorial, I just changed it slightly a little bit because I still define a resource quota for CPU and memory, but then I modified the resources on my cluster to actually play with a stateful set, so a different type of Kubernetes apps. And as we can see, on the Minikube dashboard, we have the stateful set which is grayed out. So in this case, I know what is the problem because I created this incoherent status myself, or sort of like this block status myself, but this is not a typically, you didn't find this one in the guide. So again, it will be a case that if we had a flowchart, then we may want to be in this scenario. So if we go to the RuleOps, here, if I refresh it, what it is, as we can see, is telling us that we need to update our resource quota because we are hitting the limit, and the stateful set which is pending is the hello pvdf, which is exactly the stateful set which is grayed out. Is telling us the reason why that is grayed out, and again, it's pretty simple to define that with some semantic declarative rule. In this case, in the stateful set, we are able to define that we are hitting the resource quota limit. And we can move now to the next example. In this other example, I take an inspiration from a guide titled Configure a pod to use a persistent volume for storage from the Kubernetes documentation, and I've done some variety on it. But the end result is that I've ended up with my Kubernetes cluster looking like this, which is quite scary. So actually, if we follow the flowchart, we may have stepped through some different type of investigation, only to maybe end up, I'm hinting here what is the problem, with a claim that is not finding the volume. So we don't have to do all this manual labor, which after a while might get indeed quite tedious and boring, because with the Drools RuleOps, we have this automatically presented to us. We need to fix a persistent volume because depending of the claim, which is in turn required by the pod. And this is pretty simple to express with a rule, because you can correlate both the claim to the one that the pod is trying to mount. And in fact here, we will need to define a volume which is allowable by the claim. And so what could have been quite a tedious job, it can be simply represented with a semantic rule in Drools. We can move now to the next demo. For the next example, we will start from the perspective of the Kubernetes cluster. So if we look at the landing page of the dashboard, everything is green, so everything is looking fine, and same for the services, all green, all seems to be fine. But I can tell you, if we were taking this from the operation perspective, there's something that is not going as we would expect. Now, if we follow the flowchart, we will have needed to step through quite a few hops before reaching what is really the problem. And I'm hinting here is something about the service selector. So we don't have to do all these tedious steps. And actually we can use RuleOps to tell us immediately what it is the problem thanks to some rule definition. For a change here, I'm going to show you RuleOps operator from the command line. So same principle as before. If I hit the command RuleOps, this is now introspecting the status of the cluster and is telling me what is the problem. First of all, it's telling me that the service selector is not finding the corresponding pod. Further, is helping me a little bit more than just a general guidance, because it's telling me that the service selector actually matches the pod name, but some other selector attributes are not matching. And I can tell you what it is here. It is matching. It is not matching for the expected version. So if we go in the service and we look at the service definition here, here is looking for a selector for hello PVDF for version 1.0 snapshot, but what I have currently running in my Kubernetes cluster is a 1.47 snapshot. So of course this is a synthetic example, but I hope we are really able to express and to show you how really these semantic rules are very helpful, because once you define them, so in this case here we have a first rule that just inspect that the selector of the service really do match some existing pod, and further we can even do some augmentation on these rules. So for instance, in this case, we are even able to say that some selector matches while others don't, and this is a partial match. This is the reason why the Kubernetes cluster may look green from the dashboard, but actually is not fine from an operational perspective, and we are really trying to ease out the resolution of the root cause so that the fix can be applied more promptly. We can move now to the next demo. Okay, next demo. So again, the Kubernetes cluster from the dashboard, everything is looking green. So everything is green here and everything is green here. But again, I can tell you from an ops perspective, there is something that is not going as we would expect. So we, just for you to know, in the flowchart, we are in the same area. But here we are playing a little bit more with what could be some intelligence brought in by the artificial intelligence or symbolic reasoning on this. So if we go to RuleOps and we ask the system to give us what is the problem, so we see that there is a problem again with the service selector. This we know, as I've hinted, but this can tell us something quite interesting, I would say. So it's telling us that the service hello PVDF has a selector which sounds like the pod name hello PVDF, although it's not an exact match. So this is of course something interesting, because the rule actually would look like this. So we are trying to match the service selector with the pod. However, the pod doesn't match the selector name. However, the selector name really sounds like what the pod has defined. So this is something that if you had to code it manually, it will be quite significant. Fortunately, symbolic AI, knowledge representation and reasoning, these are natural idioms when you define a semantic rule. And so we can make use of this in this case. This is a synthetic example, but I hope it really showcases what is the power of really symbolic AI reasoning when you apply to cluster operation and the debugging of your Kubernetes cluster. With this, we can move to the next example. Okay, next example. So in this case, again, we are in a Kubernetes cluster where, accordingly to the dashboard, everything is looking fine. Same for the service, but we know the drill. There is something that from operation I can tell you is not working as we would expect. In this example, we are further down in the flowchart, and we are about the problems with the target port and container port association. So RuleOps, of course, can tell us this one immediately. Is telling us that the service is defining some target port, which is not found in the expected container port that is targeting to. And this can be quite well expressed with a rule combining really different type of data models that are in your cluster with also existential operators. So as you can see, is looking for the service port, the pod, and then the container port in the container of the pod is missing for the target port. So of course, this is something that seems very lean semantically, but if you had to code it manually in an imperative style, it would have been quite significant again, and it might be prone to bug then in a code. Fortunately, this is a way where you can define it semantically. So defining it declaratively, like a semantic rule, really helps a lot to understand which are the relations between your object model, and it can help you to really understand the problem more easily. And while the visual diagram from the flowchart definitely helps, so it's really helpful to have these kind of resources. Our point with these examples is to really showcase how with a semantic rule, in this case in Drools, you can define with symbolic AI and knowledge representation and reasoning the same semantic concept actually with powerful operators, and you can have as an end result an application, a capability in general that you can use as a tool to support your operations and the debugging activities of your operations. And that is all for today's video. I really hope that we were able to showcase through this presentation a lot of the ideas, a lot of the opportunities in this RuleOps, through this RuleOps demo. So again, this is a shout out also to my colleagues, Luca and Daniele. Indeed, please do reach out for us if you found this content interesting. These are some ideas that we wanted to explore. And with that, I again thank you for your attention. I hope to hear from you, and to the next one. Bye.